In this lesson, we will learn about multiples and common divisibility tests. First, a multiple is a number that can be divided by another number without a remainder, or it can also be defined as the product of one whole number and another whole number. I made this multiplication chart here to help show the multiples of different numbers. For example, if we look at 3, this is going to be 3 times 1. 3 times 1 is 3. Now, if I multiply 3 and 2, we get 6. 3 and 3 is 9. 3 and 4 is 12. And you can see here, each one of these numbers is a multiple of 3. We can divide each one of these numbers by 3 and get a whole number. If we were to look at 5, each one of these numbers in this row is divisible by 5. That makes these numbers multiples of 5. This brings us to our next point, the common divisibility tests. These tests are ways that we can check numbers to see if they are multiples of a certain number. And in this video, we will go over the divisibility tests for numbers that have multiples of 2, 3, 4, 5, 6, 9, and 10. There are other rules that exist for some numbers that we have missing, but these are going to be the easiest ones. Our first test is the divisibility rule for 2. Our rule here is that the number is even. If the number is even, that means it is a multiple of 2, or that it can be divided evenly by 2. We're going to check our first number. We have 734. We're going to ask ourselves, is this number even? This number is even because it ends in a 4. So this is divisible by 2. If we look at 901, and we want to know if this is divisible by 2, our rule is the number is even. This number is an odd number because it ends in 1. So this number is not divisible by 2. Our second divisibility rule is for the number 3. This one's a little interesting. The rule is the sum of the digits is divisible by 3. Our first example, we have 435. We want to know if this is divisible by 3. What we're going to do is we're going to add each of these digits together. We add 4 plus 3 plus 5. And find out what this is. We have 4 and 3 is 7, plus 5 is 12. We can do this again by adding the digits, or we can stop here and see if 12 is divisible by 3. If 12 is divisible by 3, then 435 is a multiple of 3. We can divide 12 perfectly by 3, because that equals 4. That means 435 is a multiple of 3. Let's check 208. The rule is we add up the digits, and if that sum is divisible by 3, then this is a good number. We have 2 plus 0 plus 8. If we add those together, we get 10. 10 is not divisible evenly by 3. That means 208 is not a multiple of 3. We can't divide 208 evenly without getting a remainder. Our next divisibility rule is for the number 4. The rule is the last two digits of the number are divisible by 4. We're going to check this first example. We have 1024. Now, our rule says just pay attention to the last two digits. If these two digits, 24, are divisible by 4, then this number is a multiple of 4. So we check 24 divided by 4 is 6. We have no remainder, and this is divided evenly. That means 1024 is a multiple of 4. Let's check 917. We're looking at the two digits at the very end, the last two digits. We're going to see if 17 is divisible by 4. 17 is not divisible by 4 evenly. If we divide, we get 17 divided by 4. This can go into it 4 times, and we end up with a remainder of 1. Because it has a remainder, that means this is not divisible evenly by 4. Our next divisibility rule is for the number 5. We want to check to see if some numbers are multiples of 5. And the rule is the last digit is a 5 or a 0. If our number ends in a 5 or a 0, then that means it is divisible by 5 or a multiple of 5. Our first number is 685. We're going to check the last digit. If it's a 5 or a 0, then we're good. Since it ends in a 5, that means 685 is divisible by 5, and it is also a multiple of 5. If we check 857, we look at the last digit. The last digit is a 7. It does not end in a 5 or a 0. That means this number is not divisible by 5 without getting a remainder. We have the divisibility rule for 6. If a number is divisible evenly by 6, or to check if it is a multiple of 6, the rule is it is divisible by 2 and 3. We need to pay attention to the rule for 2s and the rule for 3s. If we take a look at our first number, 528, we're checking for the rule for 2, and that is if it's even. So the rule for 2, if it's even, we check the last digit. 8 is an even number. That makes 528 an even number. We're going to check the rule for 3. If we remember, the rule for 3 is we add up the digits, and if the sum of those digits is divisible by 3, then 528 is a multiple of 3. So we're going to check. 5 and 2 is 7, plus 8 is 15. 15 is divisible by 3, and it is 5. Since this doesn't have a remainder and it's divided evenly into it, that makes 528 divisible by 3. Since it's divisible by 2 and 3, it is divisible by 6. Let's check our next number, 602. First, we're going to check to see if it is divisible by 2. Since it ends in an even number, it is divisible by 2. Now we're going to check if it's divisible by 3. We're going to add the digits together. We get 6 plus 0 plus 2 is 8. Now we want to check if 8 is divisible by 3, if this can be divided evenly. This cannot be divided evenly by 3, and if we double check, 3 goes into 8 2 times, and it has a remainder of 2. Because of this remainder, it is not divisible evenly by 3. That means 602 is not a multiple of 6. We're on to the divisibility rule for 9. The rule is the sum of the digits is divisible by 9. This is very similar to the rule for 3, but in this case, the digits need to be divisible by 9. Let's check our first example. We have 513. The rule is we need to add the digits together, find the sum. We have 5 plus 1 is 6, plus 3 is 9. Now we want to check, is 9 divided evenly by 9? 9 divided by 9 is 1. That means 513 is divisible by 9. Let's check to see if 903 is divisible by 9. The rule is we add up the digits together. We have 9 plus 0 plus 3. 9 plus 3 is 12. Now we want to check, is 12 divided by 9 evenly? 12 divided by 9 will be 1 with a remainder of 3. This is not divided evenly because it has a remainder, and that means 903 is not a multiple of 9. And our last rule is the divisibility rule for 10, and that rule is the last digit is a 0. We got to remember we're talking about whole numbers here. We have 490. We want to see if this is divisible by 10. We check the last digit. This ends in a 0. That means 490 is divisible by 10. Let's check 319. We want to see if this number is divisible by 10. We're going to look at the last digit. This last digit is a 9, and it doesn't end in a 0. That means this number is not divisible evenly by 10.